This is page 2 of the 2016-2017 Competition 2. Problems 12 through 21. All right, so we have a quadratic function here, and we are substituting in -1/2 for your x value. So this is in function notation. F of x is just another way of saying y. It means the function of x, really. And so we're plugging in -1/2 for x. So we have 9 times -1/2 squared plus 3 times -1/2 plus 1. Well, -1/2 squared is going to be positive, so the negative times the negative is a positive 1/4. So we have 9 times 1/4 plus -3/2 plus 1. Well, 9/4, well, 9 times 1/4 is just equal to 9/4 minus, well, we need, in order to combine them, we need a common denominator. Our common denominator here is going to be 4, right? So I'm going to multiply both the numerator and denominator by 4, so, sorry, by 2 to get my 4. So I'm going to get 6/4 plus 1. 9 minus 6 is 3. So we get 3/4 plus 1 is equal to 7/4. So that is my answer up here. This is probably the toughest problem on the lot, but it's not too bad. Number 13, what angle is formed by the hands of a clock when it is 2:37? So I'm going to draw a clock. Pretty good circle. And I'm going to label it 12, 3, 6, 9. And you're probably going to want to label this even in the competition. And so 2:37. So the hand is somewhere in between the 2 and the 3, and the minute hand is at the 37. Well, right away, we can see that we have 1, 2, 3, 4 wedges. And in each wedge, we have 30 degrees. Why? Well, because there are 360 degrees in the whole circle, and we have 12 wedges. 360 divided by 12 is 30. So right now we know we have 1, 2, 3, 4. 4 times 30 is 120 degrees. But we have 2 other angles that we need to deal with, these 2. Let's take this one, because the math is a little bit quicker. So right now we know that this is at the 37. That's, and in between the 7 and the 5 there are 5 minutes, right? And we have gone through 2 of them. So that means we're 2/5 of the way across this wedge. Well, 2/5 of 30 is 12. So that means we have another 12 degrees. But wait, the hour hand is also moving. And so we have 37, so how many more minutes do we have until 3 o'clock? We have 23. So we have 23/60ths here. So we have 23/60ths remaining in the hour. And this is going to be equal to something over 30. Well, why 30? Because there are 30 degrees in a wedge, in each wedge. So what did I do to go from 60 to 30? Well, I divided by 2. So what am I going to do here? I'm going to divide by 2. And 23 divided by 2 is 11.5. Which means I have a grand total of 143.5 degrees. So number 14, what is the cost difference, round to the nearest penny, of a coat that is originally priced at $85 when you have a 20% discount and if you have a 15% discount followed by a 10% discount. So I'm going to use a calculator on here. Although it's fun to watch me do math crazy fast, I think you'd rather watch other things. So here is how we're going to do it. So first things first, $85 and 20% off. Well, that means that 80% of the cost is remaining, and 80% is 4/5. So the first thing I would do, and obviously I'm just doing this by hand here, is I would reduce the fraction. So 5 goes into 8 once with 3, 17, so 17 times 4. And then 17 times 4 is what brings me to this, right? So that means our first option, we have a cost of $68. Now, in my second option, I have 15% off. Now, the first thing that I'm going to do is I'm going to find 10%, and 10% is 8.5, right? 5% is half of that, so that is 4.25, right? So 15% off of 85 is going to be $12.75, I hope. Let's double check. So we have 85 times 0.85. All right, and so obviously I found, so 0.15 times 85. Yeah, so we are good to go. So let's just double check. So 85 minus 20.75. Time now. 2.5. All right, there we go. All right. So, but then we have a 10% discount, right? So that means I have 90 remaining. And so if you do the whole math, you end up with 65.025. Now, when it says, and this is my interpretation, was the cost difference rounded to the nearest penny, it's not telling you to round after each round. That means round at the end. That's how I interpret this. And you can't just lop anything off of it anyway. So I'm going to go $68 minus my 65.025. And so I get $2.97.5. But wait a second. 97.5. If we're using normal rounding rules, that's going to be 2.98. In the answer key, they have 0.97, but it depends on when you decide to round. All right, number 15. A combination lock has 4 numbers, the digits 0 through 9. How many different combinations could this lock have? All right. Now, there's only one right answer, but I can address a common misconception. This is not a combination, even though you have the word combination. And this is because in a combination, you cannot have repeats. So we're not going to do 10C4, because that would alleviate any our ability to have the same number multiple times on a combination. Now, there are some combination locks that do not allow repeats, but this does not specify. So the best we can do here is to realize we have 4 digits. The first digit could have 10 possible numbers, including 0. The second one can have 10, third one 10, the last one 10. So when you multiply 10 times 10, that's 100, times 10, that's 1,000, times 10, that would be 10,000. All right. A wedding cake weighs 3.6 pounds. I like cake. If the cake needs to be served to 48 people, how many ounces of cake can each person have to distribute it equally? This should not be here. Anyways. So 3.6 pounds. Well, we need to figure out how many ounces that is, right? So you're going to do 3.6 times 16. In the interest of time, I will go ahead and do 3.6 times 16. All right, and so that's how many ounces we now have. And so we're going to divide it amongst the 48 people, and we get 1.2 ounces per person. I was all excited about the 3.6 pounds of cake, but if I'm looking at 1.2 ounces, that doesn't sound like so much. I want more cake. All right, put it over here. All right, the mean of a set of 11 numbers is 19, and the mean of another set is 29. Sorry, a set of 29 numbers is 50. What is the mean of the combined set rounded to the nearest tenth? All right, so if I have 11 numbers with an average and mean of 19, I'm going to go ahead and multiply that out. That's going to be, do you remember that cool way of multiplying 11s? It's 11, so it's 1 and a 9, and then you add these two numbers to get me 10, so this is 2. Did that work? We'll find out. Yeah, it works. Look at that. All right. If you want to learn how I did that, talk to me later.
That was cool.
That was cool. All right. So that's the total of the sum of all the numbers. So if we have 29 numbers and the mean is 50, well, let's multiply 5 times 9. 5 times 9 is 45. Carry the 4. 10 plus 4. That does not seem right. Let's try again. Oh, there is a 0 there. Right, okay. Then I can double check this. All right, so I'm going to add it to the 209. And now I'm going to divide it by the total numbers that I have. Well, I have 40 numbers, right? So I'm going to divide it by 40. Oh my goodness. Gotta love it when technology doesn't work, right? And I'm going to divide that by 40. And so, rounded to the nearest tenth, I'm going to have 41.5 as my mean. All right, number 30 or 18, number 18. What is the area of a right triangle with side lengths 14, 48, and 50? Well, it's a right triangle, right? And I know the hypotenuse is the longest side. And so that means 14 and 48 are my side lengths. So the area of a triangle is base times height divided by 2. So I'm actually going to divide that by 2 first. So we have 14 times 24. And so we have 240, that's 10 times. And then 4 of 24 is going to be 96. So add those two things together and you get 336. All right, number 19. What base 10 number would be written in base 5? All right, so we have 4, 3, 2, 1, 0, or blast off. So we have 4 to the 0, which is 1. We have 4 to the first, which is 4. Yes? Oh, not much. We only have three problems, including this one. 4 to the second is 16. 4 to the third is 64. 4 to the fourth is 64 times 4. And it's like 256, I think. Oh, look at that. So I have 4 groups of 256. So that amounts to 1,024. I have 3 groups of 64. It gives me 192. I have 2 groups of 16, which is 32, and no groups of 1, let's see, make sure I have all the groups. Oh, I have one group of 4. How dare I forget that? So I have 2 plus 2 plus, 2 plus 4, which is 6. 6 plus 4, which is 10, 12. Carry the 1, it's 10, 15, carry the 1, 2, 1. So my number is 1,000. That is interesting. Is it possible? That does not seem right. So I will double check it. This time I'll use a calculator. 4 times 256, right? 364 times 3 plus my 1024, right? Plus my 32. Plus my 4. So I get 1,252. Okay, what base 10 number would be written? That is interesting. I'm getting a different answer. Well, I will double check that later. I'll get back to you. What is the average of all the prime numbers? Well, unless it's bothering me, right? 4 to the 0 is 1. For the first is 4. For the second, yes. For the third, yes. For the fourth, yes. I have 1, 2, 3, 4, 5 numbers. For that, yes. So, it's interesting. All right. What is the average of all the prime numbers between 6 and 28? All right. Well, let's make a list. 7, 8, no. 9, no. 10, no. 11, 12, 13, 14, 15, 16, 17, 18, 19 is prime. 20, no. 21, 22, 23, 24, 25, 26, 27. Oh, no, those are right. So what is the average? So we need to add all these together. So we have 7 plus 11 plus 13 plus 17 plus 19 plus 23. I get 90. I have 1, 2, 3, 4, 5, 6. So 90 divided by 6, I get 15. And finally, a chess game began at 10:32 a.m. and ended at 12:46 p.m. How many minutes did the game last? Well, from 10:32 to 12:32 is obviously going to be 2 hours, right? So that is 120 minutes. Well, so how many more minutes do we need to go? Well, 8 more to get to the 40 plus 6 to get to the 46. 8 plus 6 is 14. So we get 134 minutes. And there we go.